Hi everyone, in this video we are going to start working on our contract. First, I'm going to change the name of the contract. It's going to be car rental platform. Then I'm going to empty the contract and our version will be 0.8.7 and above. The name of the contract is car rental platform. Alright, now we are ready to start writing our contract. First, we are going to start with the outline of the contract. It's important because starting with our outline, we are focusing on the logic. When we implement the functions and everything in our contract, we will focus on the implementing part. By separating the logic part and the implementation, first we will focus on the logic and then we will focus on the implementation. We won't be thinking about the implementation while we are working on the logic, and vice versa. By doing this, we are going to minimize our error margin. So, first, we are going to have a section called data. This will hold the data in our contract, like the owner address, our mappings, our structs, and everything. In this data section, first we will have our counter. We are going to have this counter so that we can use it with the IDs of the cars when we create the cars. Then we will have the part for the owner where we hold the owner address. And then we are going to hold the total payments made to the contract. I'm going to say total payments. We are holding the total payments, we are storing the total payments made to the contract so that the owner of the contract can take these tokens from the contract if needed. We are holding the total payments, not the whole balance, because we want to subtract the balance of the users so that the owner can only get the tokens that are paid to the contract and not the tokens that the users are holding as balance. Then we will have our user struct and we will have our car struct. In our car struct, we want to have an enum so that we can hold the status of the car if it's retired, in use, or available. For that, I'm going to have an enum and I'm going to say to indicate the status of the car. Next, we will have our events, our user mapping so we can track the users. Same for the car. And we will have our constructor. After the data section, we are going to have our modifiers. We may have a couple of modifiers, but so far we are going to use only owner modifier for sure, so I'm adding the only owner here. And after the modifiers, we will have our functions. It's important that you write your functions in an organized way. So first, we are going to put our execute functions, then our query functions. Execute functions are the functions which alter the state of the smart contract, and query functions are the view functions where we just receive data from the contract without changing anything in the contract storage. For the functions, first let's say execute functions. Our first execute function will be set owner function and its constraint will be only owner, meaning that this function can be called only by the owner. Then we will have a function called add user and constraint for this function will be non-existing user. So that to add a user, first the user shouldn't be added before so that we can add for the first time. So our constraint is non-existing. After that we have a function to add car. This can only be called by the owner and non-existing car. The car should not exist so that we can create the car, add the car in the first place. Then we will have a function to edit car metadata. This can only be called by the owner and it should be a existing car. So with this function, we are going to update the metadata of our car, which is everything other than the status of the car. For the status, we will have a separate function called edit car status. This will be only owner, and it should be an existing car. After edit car status, we have our checkout function. It should be an existing user. Is car available, because they can only rent the cars they are available. If a car is in use, then they cannot rent the car. If a car is retired, then the user cannot rent the car. The only way the user can rent the car is that the car is available. And user has not rented the car. If a user rents the car, they cannot rent another car. And users should not have any debt. After our checkout function, we have our check-in function. It should be an existing user. And user has rented a car, so that they can return the car. After this, we are going to have the deposit function. It should be an existing user. So what's going to happen with our contract is that first users will deposit tokens through our deposit function. Then after they check in the car, they will have a debt. With the token they deposited before, they can pay their rent with our make payment method, so that they can rent another car after they cleared out their debt. So after the deposit, we will have a function called make payment. It should be make payment. It should be an existing user. User should have debt to pay, and they should have a sufficient balance so that they can pay their debt. After this, we are going to have withdraw balance function, so that the users can withdraw the tokens they deposited earlier. And it should be existing user, obviously. After withdraw balance, we have withdraw owner balance function. So this function is for the users who want to get their tokens back that they deposited as their balance and they haven't used it yet. And this function is for the owner, so that owner can retrieve the tokens from the contract. This will be only owner. And then we will have our query functions. Our first query function is the getOwner function. Then we will have our isUser function. And also we will have the getUser function, and for that it should be an existing user. We need a function to get a specific car, and it should be an existing car, otherwise we cannot retrieve the data. And we will have a function called getCarStatus. So with getCarsByStatus method, we will be able to filter the cars based on their status, so that we can use them on our frontend. We will have an internal function called calculateDebt, getCurrentCount, getContractBalance, and this can only be called by the owner. Also getTotalPayments. This is also can only be called by the owner. And that's it. That's the outline of our contract. Let's see what we did. First, we have our data section. In this section, we will have a counter. We will have the owner. We will store the total payments that are done to the contract. Also, we will have our user and car struct. We will have an enum so that we can hold the car status. We will have our events, mappings, and constructor. Then we will have our modifiers. For now we only have the only owner modifier. If we need, we can add more. Then we will have our functions. Our functions can execute functions or query functions. First we are going to implement the execute functions and then the query functions. For the execute functions we have the set owner, add user, add car, edit car metadata, edit car status, check in, check out, deposit, make payments, withdraw balance, withdraw owner balance. We talked the difference about them. And then we have our query functions. For this we can get the owner, we can check if this address is a user or not with our isUser method. Then we will have methods to get the user and a car. Then we will have a method to get car by its status, so we can filter out the cars and use it in our front end. We will have the internal function to calculate the depth of the user. Then we will have the function get current count so that we can see how many cars we have. And then we will have two getter methods for the contract balance and total payment. In the next video, we are going to implement this outline. Thank you very much and see you on the next video.